Welcome to your 7.1 notes, and this is going to discuss further right triangle trigonometry. So far you've talked about special right triangles, and what if they're not special? What do you do? So here we are given a right triangle. We refer to C as our hypotenuse, and A and B are our legs. I guess I should just say leg. All right. The other thing I want to mention before we go into the definitions is how we label triangles is your side lengths are lowercase and your angles are uppercase. And across from your angles, so like C for instance, across from that is your angle C. And this is always the case. So across from A is angle A, and across from B is angle B. So that is always how you label. That's really important so you don't mess up your answers. So the following things are definitions. At this point, you are accepting them as definitions. You will learn the proof of these. I want to say Calculus 3, 253 is my memory. But right now, you're just accepting the definition. So all 6 of these things, so let me just read them to you. Sine of theta, cosine of theta, tangent of theta, cosecant theta, secant theta, cotangent theta. These are functions, okay? So if you remember in your 111 days, your input is your theta, and the output, what this function will spit out, is a ratio of side lengths. So sine of theta, so you need to have an input, so make sure you have theta. And what that is that's right there. This is theta. It's a Greek letter, and it means it's standing for our angle in this problem. It could be other things, but typically it's an angle. So the definition of sine of theta is opposite over hypotenuse. So the key thing is to stand where your theta is, because that determines what is opposite and adjacent to you. So before I actually even go further, I'm going to get rid of this stuff so I can actually write it. Let's determine some things. So C is always our hypotenuse. That won't change because it's across from your right angle. It's the longest side. And if you're standing at theta, is A opposite or adjacent? Well, A is opposite. And B is adjacent. Now realize that changes depending on where you stand. If you stand up here, no longer will A be opposite. Okay, so it all depends on where your theta is. So I want to know here what ratio in terms of A, B, and C is opposite over hypotenuse. Okay, well, opposite theta we decided was A, and hypotenuse is C. So cosine of theta, that definition is adjacent over hypotenuse. Well, adjacent is B and hypotenuse is C. Tangent, that definition is opposite over adjacent. So opposite A over adjacent B. A nice way to have this memorized is something known as SOHCAHTOA. So what this means is this is sine, that S, is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. This one's really, seriously, I think sometimes I still use it. Especially with the TOA, people will mess that up often. We'll put adjacent over opposite. So you sit there and you go, SOHCAHTOA, and it helps you remember the order. Now for the next 3 functions, they are known as your reciprocal functions. And if you remember, reciprocal, like if I had 3/4, my reciprocal is known to be 4/3. So cosecant of theta is the reciprocal for sine, and it's abbreviated CSC. And now it's just I'm just flipping this ratio. So my hypotenuse is C and my opposite is still A, because your theta is still located where it was. Secant of theta, abbreviated SCC, don't say sec, okay, say secant, is hypotenuse over adjacent. Well, that ratio would be C over B. And then cotangent, please don't say cot, of theta is adjacent over opposite, so that would be B over A. So all I'm talking about right there are some definitions of new functions we're being introduced to. You can use any of these. I will say, let me go here real quick. These three are typically the ones we use when we're evaluating because they're easy to find on any calculator. You can use the reciprocal functions, but it's just kind of like a pain to find it. Okay, so let's do example 1. It says find the exact value of the 6 trig functions. This is really important. Exact, okay? Really, really important. Means you're not going to give me a decimal at all. All right, exact means you do not round. Well, I want to find it of theta. The problem is I have 3, I have my hypotenuse, but I don't know this side. And so how do we find that side? Well, if we're in a right triangle, we go ahead, and I'm just going to label it X for convenience. We do Pythagorean Theorem. So 3 squared plus X squared equals 4 squared. So we get 9 plus X squared equals 16. Take away the 9, we get 7, square root. So we get X is the square root of 7. Okay, so now I can find some ratios. So sine of theta. So don't forget this piece. That's what all students forget. The ratio. Okay, so I'm going to sit here and be like, oh, I forgot. No, I'm going to say so O. So it's opposite. So what's opposite U? Root 7 over so H, the 4. All right, cosine theta. Ka, so adjacent. What's adjacent to your theta? 3. And what's your hypotenuse? 4. Tangent of theta, toa, opposite, root 7 over A, which is adjacent, 3. And then to find the reciprocal functions, cosecant of theta, so cosecant goes with sine. I know that's kind of misleading because people want to think the C's go together. That's just the reciprocal, so it's 4 over root 7. But like we discussed, we can't leave a radical in the denominator. So I get 4 root 7 over 7. Secant of theta, the next definition is just the reciprocal of cosine of theta. So that's 4 over 3. And then cotangent theta is the reciprocal of tangent. So that would be 3 over root 7. But what do you know? I can't leave it like that. So I get 3 root 7 over 7. Oops. Let's go ahead and make that look a little bit better. 3 root 7 over 7. Okay, I'll see you next time.